What's up, scholars? We finished off talking about parallelograms, and now we're going to talk about special types of parallelograms, namely a rhombus, rectangle, and a square. So a rhombus is a parallelogram, meaning it has all the things that are true about a parallelogram, like its opposite sides are parallel, its opposite sides are congruent, its opposite angles are congruent. Consecutive angles are supplementary, the diagonals bisect each other. I think that's it. It's got all those things, plus it's got all sides congruent. All sides congruent. A rectangle, also a parallelogram, but it has all angles congruent. And a square is a parallelogram that has all the properties of a rhombus and a rectangle. So it's got all its sides congruent and all its angles congruent. All sides congruent and all angles congruent. So I want to draw a quick Venn diagram here. Let's call this circle all the rhombuses. And this circle will be all the rectangles. And where they overlap, right in the middle, those are the squares, the things that are both rhombuses and rectangles. A square is a rhombus and a rectangle. Cool, huh? Yeah, pretty cool. All right, so let's draw some pictures. Let's draw a rhombus. It's going to be a parallelogram with all sides congruent. It's got opposite sides parallel, and all of its sides are congruent. Now a rectangle, parallelogram, it's got opposite sides parallel, and all its angles are congruent. Well, if all its angles are congruent and all the angles add up to 360, and there's 4 angles, that means all of these angles are 90 degrees. Very good. They're all right angles. And a square has all of these properties. All the sides are congruent and all the angles are congruent. See if I can make that happen. All the sides are congruent because it's a rhombus, and all the angles are congruent because it's a rectangle. Okay, so now we're going to use this Venn diagram to help us answer these questions. Decide whether the statement is always true, sometimes true, or never true. Is a rhombus a rectangle? Does a rhombus ever intersect with this rectangle? Well, yes, here in this part right here. A square has both of these properties. So a rhombus is a rectangle sometimes when it is actually a square. So sometimes. Is a rectangle a parallelogram? Well, yes, that's in the definition. A rectangle is a parallelogram with all angles congruent. So that's always true. Is a parallelogram a rectangle? No, not necessarily. Parallelogram could be a rhombus, could be a rectangle, could be a square, could be a regular parallelogram, but sometimes it's a rectangle. All right, is a rectangle always a square? No, but sometimes it is. It's sometimes a square. In that overlapping part right here. Is a square a rhombus? All the time. A square is always a rhombus. All right. A square is something that has all sides congruent, always. So it is always a rhombus. Nice. All right. Example 3, EFGH is a rectangle. I guess I better draw that. EFGH is a rectangle. Opposite sides congruent. All angles are right angles. K is the midpoint of FH. I guess I'll draw that too. K is the midpoint of FH. So that means these two segments are congruent. If EG is 8x minus 16, what are EK and GK? Well, EK and GK aren't on here either, so I guess we should draw this. That was another diagonal, and since a rectangle is a parallelogram, we know the diagonals bisect each other, so we know that these segments are also congruent. Okay, so now let's go back. What are EK and GK? Well, we know they're equal to each other. We know EK equals GK. We have an expression for EG, so let's think about what we know about EG. EG is made up of EK and KG, or GK, since that's what I used before. Then let's do a little substitution. EK is equal to GK, so let's plug that in here. Always with the coughing at, can get it together. So EG is GK plus GK. So EG is 2GK. So I could divide both these sides by 2. So GK is actually equal to, that crosses out, 1/2 of EG. So GK is 1/2 of, EG was 8x minus 16. So GK is half of 8, which is 4x, and half of 16, which is 8. And EK is the same thing, because they were equal to each other. So EK and GK are equal to 4x minus 8. Cool beans. All right. We have some corollaries about these special quadrilaterals, rhombus, rectangle, and square. So we can go right to knowing that a quadrilateral is a rhombus if and only if all sides are congruent. All sides are congruent. If you know all sides are congruent, you immediately know we have a rhombus. A quadrilateral is a rectangle if and only if, what do you think? Yeah, all angles are congruent. You know all the angles in a quadrilateral are congruent, you know you got a rectangle. And the square corollary says a quadrilateral is a square if and only if both of these things are true. All sides and all angles are congruent. All sides and all angles are congruent. Very good. All right, let's flip over to the back. In the diagram to the right, ABCD is a rhombus. What does it mean to be a rhombus? It means all sides are congruent. All sides are congruent. So, how do we solve for x? All these are equal to each other. 2x equals 3x minus 16. You're going to solve this and show me. Solve and show me next time when you come back. Okay. In this figure here, WXYZ is a square. So that means all sides are congruent because it's a rhombus, and all angles are congruent because it's a rectangle. So, what do we know? Well, I can set these equal to each other, but that's not super helpful because they have different variables. Let's look at this one. 8x plus 10 equals what? Well, these are all right angles, so it equals 90. So you're going to solve this and show me. So once you've done that, then you can solve for x and plug in here. And then you can solve for y because these will be equal to each other. So x plus 4 will equal to y. So you'll solve and show me. You guys are doing fantastic. All right, there's a couple other theorems we can talk about. I'm not going to make you prove them. We're just going to get to use them. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So let's draw some diagonals. Whoa, let's try that again. All right, there we go. Okay, a parallelogram is a rhombus if its diagonals are perpendicular, meaning all of these guys are right angles. Parallelogram is a rhombus if and only if its diagonals are perpendicular. Man, it's the season, huh? A parallelogram is a rhombus if and only if each diagonal bisects the pair of opposite angles. So bisecting the pair of opposite angles means this diagonal splits these two angles. Man, I tried to get out of that perfectly. Okay. Not good. This diagonal splits these two angles perfectly, and this diagonal splits these two perfectly. Okay? So it's also a rhombus if the diagonals bisect the pair of opposite angles. And finally, a parallelogram is going to be a rectangle if and only if its diagonals are congruent. Its diagonals are congruent. So it's a parallelogram, so its diagonals bisect each other. It's a rectangle if those diagonals are also congruent. So that actually means these guys are all congruent to each other. Right? The diagonals themselves are congruent, and the diagonals bisect each other. So each of these sections are congruent. All right. You're going to do these 3 examples and show me next class. And that's all of our notes about our special parallelograms. So do these and show me. Right? So you've got these 3 questions to do and these 2 questions to do. Great job, everybody. I'll see you next time in class.